Okay, so we are going to go through the first part of our Concept 2 notes on measurement. So the best measurements are both accurate and precise. So accuracy is the degree to which the experimental result agrees with the accepted value. So accuracy is how correct your measurement is. And precision is the degree to which measurements agree with one another. So this is how specific your measurement is, or how consistent multiple measurements are to each other. Right, so you need to make sure that you know and understand the difference between accuracy and precision. So let's look at these examples here. Right, so our very first one is precise and accurate. Right, they're precise because they are all close together, and accurate because they're all in that center circle. Right, and then our second one over is precise because they're all kind of clustered together, but it's not accurate because they're off middle, right? They didn't hit that target in the center. So then the third one here in the bottom left is accurate because they're all in that kind of bullseye area, but not precise because they're far off from one another. They're not all in that same clustered area like we saw up above. And then the final one, it is not accurate because they're out of the middle, and it's not precise because, again, they're spread out very far from one another. Right, so this is a good visual description of the difference between accuracy and precision. All right, so let's talk through this example. So if a student knows 85% of the material for a test, but makes a 70% on the test, is this measurement accurate, precise, or neither? So it's not precise or accurate. Right, so let's think through that. So they know 85% of the material, right? So for it to be accurate, they would need to know really 100% of the material, right? And it's not precise because they've only got 70% instead of that 85 in which they know. All right, for our second example, Mrs. Joyner's dog Millie is known to weigh 65 pounds. She goes to the vet and is weighed 3 times at 71, 70.5, and 71.1. Are they accurate, precise, or neither? So they're precise because they're all very close together, right? But they're not accurate because it's well over her known weight of 65. All right, so when we typically are making measurements in the labs that we'll do to collect data, you've got to be able to find the average. So to find an average, you add up all of the values and divide by the total number of values. So Callie measures her flower to be 30 centimeters tall. Jeff measures the plant to be 45 centimeters tall. Liam measures the plant to be 36 centimeters tall. So we need to find the plant's average height. So our 3 heights are 30, 45, and 36. So we're going to add those 3 numbers together and then divide them by 3 because we have 3 values. Right, so you have 111 divided by 3, and we have 37 centimeters. Right, so in physical science class, it's always very important to make sure that you have your unit value as part of your answer, right? Because otherwise, we could assume that it's 37 miles, meters, inches, anything, right? So we need to make sure that we are including our units in our answers. All right, so standard units. A standard is an exact quantity that people use for comparison, right? So we have to have kind of a standard or something to go by in order to make comparisons. So the SI unit system is a system that's used by scientists around the world to make measurements, right? It's also more commonly known as the metric system. Right, so each type of measurement has a base unit, and prefixes are used with base units that are based on multiples of 10. Right, so we're going to talk about units first for length. So length is the distance between any 2 points. Right, and the standard unit for length is the meter. Right, we typically use a meter stick or a ruler. Mass is the amount of matter in an object. And the unit for mass, the standard unit for mass is the kilogram. And it's typically measured using a digital scale or a spring scale, right? So this is a picture of a spring scale, right? You like hook the weight on the bottom of it, and then this kind of slides up and down, and we'll show you how much mass it has. Right, and this, as we saw in class the other day, this is our digital scale, where you just set the object on top. Right, so volume is the amount of space occupied by an object. So typically we measure volume in liters. We measure volume typically with a graduated cylinder, or it can be calculated with a geometric equation. When you're measuring with a graduated cylinder, you always measure to the bottom of the meniscus, which is the curve in the liquid. Right, so it's this right here. So when you look at it at eye level, there's a slight curve in that liquid. Right, and you always want to measure to the bottom of that for it to be accurate. Okay, time is the interval between two events. The base unit for that is seconds. Right, and we typically will measure that with a stopwatch. All right, temperature is the amount of heat in an object. Right, the base unit for that is actually a unit called Kelvin. The metric system uses Celsius, but in the SI system, we technically use Kelvin. And the US uses Fahrenheit. Right, so we will measure this with a thermometer. We learn a more scientifically accurate definition of temperature later on in this course, but for right now, we'll just go with the amount of heat in an object. So we're going to focus today on temperature conversions. So if you have to find the amount of Kelvin in something, you're going to take whatever the temperature is in Celsius and add 273. So this formula goes from Celsius to Kelvin, right? And notice that Kelvin does not have a degree symbol. Right, when you need to go from Fahrenheit to Celsius, you're going to use this formula here, which is 5/9 times the Fahrenheit minus 32. And remember, order of operations, you always want to do parentheses first. So you make sure and you subtract your 32 before you multiply by 5/9. All right, and then the last one takes us from Celsius to Fahrenheit. So this one you multiply first, right, because it's in those parentheses, and then add 32 last. So make sure and write these down. I will give you all a sheet that you can write your formulas on, and we'll keep that throughout the year that you can use on tests and quizzes. But in the meantime, make sure that you've got them, and I would highlight them in your notes. That way you can easily find them to use while we do our practice sheet today. So let's do an example. Mrs. Smith is going on vacation to Greece for her anniversary. The weather is predicted to be 27 degrees Celsius. She lives in the U.S., though, and doesn't know what to pack for this weather. Help her determine the temperature in Fahrenheit so she can pack. So we're going from Celsius to Fahrenheit. So we know that Celsius is 27. We need to find what it is in Fahrenheit. So we're going to use this formula here. Right? So degrees Fahrenheit is equal to degrees Celsius times 9/5 plus 32. So 27 times 9/5 plus 32. So we take our number, plug it into our formula. Right? So 27 times 9/5 gives us 48.6. And then we add our 32 to get 80.6 degrees Fahrenheit. Now, I want you all to make sure that you are writing down the formula and showing me your work. So show me where you plug the number in and what you get as you go. So you have to make sure and show me all of these steps, right? This is also a good step to show. It's always good to write down the information you have and what you're trying to find. Okay, so I want you to look at these, take a minute, pause the video, try and work through these practice questions and see how you do. Okay, assuming that you have now paused this video, I'm going to go through and we'll talk through the answers. All right, so you should get 73.4 for the first one, 8.89 for the second, and 301.3 for the third one. Right, so this one's tricky. You've got to go from Fahrenheit to Celsius first, and then from Celsius to Kelvin. Right, so there's no straight conversion from Fahrenheit to Kelvin. You can't do that. You always have to go from Fahrenheit to Celsius, then to Kelvin. Okay, so let me know if you all have any questions. Your assignment is page 14, which is temperature conversions. So make sure you're using those formulas and a calculator. If you don't have a calculator at home, the one on your phone is perfectly fine. Just make sure that you are paying attention to the order that you solve your problems in.